Welcome to Train Signal. You're watching a lesson on binary math. Yes, that's right. I said binary math. I'm really sorry. I know a lot of people really don't like those math lessons, but you're going to have to take this one. This is something that's going to help you to understand a lot of the other IP addressing related subjects that we talk about in this course. The one thing I do promise you is that in this lesson, I'm going to teach you a very easy way to understand binary math. So to get things started with this binary math lesson, I'm going to keep this real simple. And I'm going to ask you a question. And I'm really asking you. Okay, so pay attention. On the screen, it says, what is this number? And I'm not going to read this number out loud. I want you to look at the screen. And I want you to say it out loud. I want you to answer me right now. What is that number? It's not a trick question. Answer me. That's right. Hopefully you said 3,482. Right? You probably thought I was going with some kind of a trick question because this is supposed to be binary stuff, right? No, it's not a trick question. In the regular decimal numbering system that most of us were brought up on, this number is pronounced 3,482. At least in English it is. But how do we know that? How do we know that this is 3,482? Well, let's talk about this. I mentioned the decimal numbering system. We learned that in the decimal numbering system, we take our numbers and we break them into certain column values. Right? We learned that we have the ones column and the tens column and the hundreds column, the thousands column. And even beyond that, we have what? The 10,000s, the 100,000s, the millions, and so on and so forth. And then we take the numbers and put them in each of those columns. Right? So we put 3 under the thousands column, 4 under the hundreds column, 8 under the tens column, 2 under the ones column. And then we multiply the number by its column value. Right? So we say 3 times 1,000 is 3,000, 4 times 100 is 400, 8 times 10 is 80, and 2 times 1 is 2. And then we add those four numbers together. Right? We take the 3,000, the 400, the 80, and the 2, add them together, and what do we get? 3,482. Now let me just take a quick guess. You're probably thinking, wow, that sure was a whole lot of double talk to get us right back to where we started. I mean, trust me, that's how it sounded to me as well. But don't worry, I didn't do that to look like I was doing some kind of a magic trick. There's a point behind this process, and understanding that point is really important if you're going to understand how to do binary math. So what I just went over with you was the way we looked at things in decimal. Now we need to see how it breaks down with decimal versus binary. In the decimal numbering system, or the base 10 numbering system, the way we determine those column values, right? When we said the ones column, the tens column, the hundreds column, the way those are technically determined is if we're in base 10, if that's the numbering system, the rightmost column is 10 to the 0 power. And anything to the 0 power equals 1. And then the next column over would be 10 to the first, which is just 10 all by itself. So there's 10. Then we have 10 squared, or 10 to the second, which means 10 times 10, which is 100. And then we get 10 to the third, or 10 cubed, which is 10 times 10 times 10. And then 10 to the fourth, and then 10 to the fifth, and 10 to the sixth. And we can continue out as many columns as we want to go through. And the other thing that we know about the base 10 numbering system is that there are 10 possible numbers that we can put in each column. Okay? In other words, in the ones column, there are 10 possible numbers we can put there. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are the 10 possible numbers. Well, if we want to work with binary, we have to understand that binary is base 2. And the same rules apply. We know that the column values are going to be 2 to the 0, and then 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth, and so on. And we also know that each column can only have 2 possible number combinations. And those 2 number combinations are 0 or 1. Okay, those are the rules. They work exactly the same. Binary, decimal, you could talk hexadecimal, octal, it doesn't matter. Any numbering system, those are the rules. Now, when it comes to figuring out the actual column values in binary, this is where a lot of people get lost. And the reason why is because exponential numbers are scary, right? You hear somebody say, Okay, well that's 2 to the 12th power. I don't know what 2 multiplied by itself 12 times is off the top of my head. So I'm going to give you a very easy way to write down the column values. And that is to start all the way on the right and say, well, we start with 2 to the 0. And we know that anything to the 0 power is a 1. Okay, so the rightmost column value is a 1. As a matter of fact, it doesn't matter what numbering system you're using, the rightmost column value is always going to be a 1. The next column over, you're just going to multiply by 2. And as a matter of fact, for each of the columns that we move along, you're just going to multiply by 2. So as long as you know how to multiply by 2, you can do this. And if you can't, don't worry. At the end of all this, I'm going to show you how to use the calculator. But basically the idea here is we start with the number 1 and multiply by 2, we get 2. Multiply that by 2 and we get 4. Multiply by 2, we get 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096, and that's all I have room for on the screen. And actually, there's another reason that I'm going to stop there that we're going to learn in a little bit. But I'll tell you what, we could keep going. And depending on how good you are at math, for some people this is a little bit easier, and for some people it's a little bit more work. But either way, most people can multiply by 2. I mean, I happen to be able to go on fairly quickly and say, let's see, 4,096 times 2 is 8,192, 16,384, 32,768. You getting the idea? I've had a lot of practice with this. I also happen to be very good at math. But all you have to do is be able to multiply by 2. But knowing these column values is very important. And the reason why is because we're going to now learn how to convert between binary and decimal. The first direction that I want to show you is from binary to decimal, meaning you're starting with a binary number. And the example I have on the screen is 10101010. That's in binary. And I want to convert that to decimal. So what do I do? Well, the first thing I need to do is I need to write down my column values. Right? So I just go ahead and start with a 1, and then I put 2, 4, 8, 16, 32, 64, 128. And I line up my 1s and 0s under those column values. From there, all you're doing is you're multiplying the column entry, right, the actual number that was entered into that column, by the value of that column. So 1 times 128, well, 1 times anything is itself, right? So you get 128. 0 times 64, well, anything times 0 is 0. So that's just 0. 1 times 32 is obviously 32. 0 times 16 is 0. And I'll tell you what, rather than going through and doing this all the way through, I will tell you there's a much easier way. 0 times anything is 0. So we can just ignore the zeros. The only thing we need to pay attention to is where the 1s are. And because 1 times anything is itself, we just need to add up the column values where there's a 1. So we simply take 128 plus 32 plus 8 plus 2 and add them up. And I've actually written it out here the same way that I know I learned it, and there's a very good chance the way you learned it in grade school. Right? Just take the numbers and you write it in a column, and you'll put it on a sheet of paper if you have to, and you can go right down the list and say 8, just go on the rightmost column and say 8 plus 2 is 10, plus 8 more is 18, plus 2 is 20. So that gives you the 0, carry the 2. Remember that from school? Carrying. That was never fun, right? But you carry that 2 and you add it to the other 2 that's there. That's 4 at 3, and now you're at 7. All right, great. And then 1, oh, there's nothing else besides the 1, so there's a 1. And you get 170. So what that means is the binary number 10101010 is equal to the decimal number 170. That's it. That's how easy it is to convert a binary number to a decimal number. Now, most people get that, and they don't find that to be too difficult, but they do struggle with the other direction. If we want to convert decimal back to binary, okay, this is where people struggle a little bit. So let's take a look at this. I'm going to hopefully simplify it so you won't ever have to struggle again. Let's take this number that we started off with, 3,482, the number we want to convert to binary. We need to write down all of our column values, and here's the thing. You need to go all the way up until you've gone over 3,482. In other words, I didn't write it here on the screen, but the very next column value after 2048 is 4096. That's bigger than the number you're trying to convert. So that's too far. Okay, that's how you know you've gone one space too far, and you can eliminate that column. The next thing we need to do is go through a series of questions. We start with 3,482, and you say, can we subtract 2,048 from 3,482? And the answer is yes, so we go ahead and do that. We take 3,482, and again, you'll notice I've written it out just like, again, how I learned it in grade school. And if you have to do it, where you actually look at this and you say, all right, 2 minus 8, oh, I can't do that, so I'll make that 12 minus 8 because I borrow from the 8, make that a 7. Okay, I'm going to spare you because I know borrowing was about the only thing scarier than carrying, right? But 3,482 minus 2,048 is 1,434. And we put a 1 under 2,048. In other words, we subtract it and put a 1 there. Next, can 1,024 be subtracted from that remainder, that 1,434? Well, yeah, it can. So let's do it. We'll go ahead and subtract it, and we put a 1 under 1,024. And when we subtract it, we end up with 410. So then we ask, well, can 512 be subtracted from 410? And the answer is no, it cannot. Okay, in other words, 512 is too big. Remember how 4,096 was too big? Well, 512 is too big. So we're going to put a 0 there. And then we ask the same question of the next column. Can we subtract 256 from 410? Yeah. So we go ahead and do it. Do the formula. 410 minus 256 leaves us with 154. We put a 1 in that column. And then we move over to the next column and say, well, can we subtract 128 from 154? Yes, we can. So let's do it. Let's subtract it and put a 1 in that column. And we're left with 26 as a remainder when we subtract that away. Can 64 be subtracted from 26? No, so we get a 0. Can 32 be subtracted from 26? No, so again we put a 0. Can 16 be subtracted from 26? Yes, it can. So we do, and we get 10, and we also put a 1 in that column. Can 8 be subtracted from 10? Yes, it can. So we do, and we put a 1 in that column. And we're left with the remainder of 2. We move over. Can 4 be subtracted from 2? Nope, it's too big, so we put a 0. Can 2 be subtracted from 2? Yes, it can. So we do. We get a remainder of 0. We put a 1 in that column. And to be more specific, at this point, now that we're at 0, we know that all remaining columns, as we continue over to the right, the answer is always going to be no, right? Nothing can be subtracted from 0. So we just put zeros for any columns we have left. In this case, there is only one column left. It's just the ones column. We put a 0 there. But what this means is that we have just converted the decimal number 3,482 into the binary number 110011010. Okay, now I'm not sure how confusing that may or may not have been for you, but again, it just comes down to just taking it one step at a time and saying what's the biggest column value that can go into 3,482 or whatever your decimal number is. Put a 1 in that column and then subtract that column away from 3,482. Take the remainder and go to the next column that fits in. Take the remainder, next column that fits in. So you go all the way across. And anywhere, if you are actually subtracting that column value, you put a 1. And if you're not, you put a 0. Now here's the really good news that I have to share with you. And that is, if you still find converting between decimal and binary to be confusing, the great news is that you can use a calculator. All Windows operating systems include a calculator. So let me go ahead and show you an example. I happen to be working with Windows 7, and this is what the calculator looks like in Windows 7. If you go to the View menu, you'll see that something that a lot of people aren't even aware exists. This is just the standard calculator. There are other types of calculators, and I will tell you if you're using anything before Windows 7, you should jump to Scientific. But this won't help us here. We are working in Windows 7, so we're going to go ahead and go to the Programmer calculator. And I apologize here. I've kind of covered up decimal and binary. those words right there. But let's just go ahead and look at the calculator. You'll see right over here, hex, dec, or des, depending on how you want to pronounce it. I can tell you it stands for decimal, so it should probably be des. Oct, and then this is either bin or bind. And again, some people will say bind because it stands for binary. So what that means is, in decimal, if I put in the number 3,482, and I come over here and very simply click this button that says switch to binary, boom, look what happens. 1101100111010. That's what we came up with before. And in binary, let me go ahead and clear this out. If I were to put in 10101010, right? That's the binary number that we originally converted. And I just click the button that says decimal. Boom, what do we get? 170, just like we had before. Now, using the calculator is not my favorite thing to do because, well, it's just, first of all, I like to continue using my brain. Okay, that's part of how I try to stay smart when it comes to math. I use my brain where I can. I write it out on paper if I have to. Don't want to have a computer or the calculator do all the work for me. But the other reason I don't like using the calculator is because, let's go ahead and jump down here to binary. And let me clear this out. Remember this binary number we had down here? Right, this 110110011010. Did you notice what I did when I was just typing that in? This is supposed to be 11011. Up here, I put 110111. Oops. Now, how quickly would you have recognized that when looking at binary, looking at a bunch of ones and zeros? It's real easy to do that, to put an extra 0, put an extra 1, leave 1 out. But watch what happens when I convert this to decimal. It's nowhere near 3,482. I've created a whole new number here. It's now 7,066. So that's the only thing that I would caution you on when using the calculator. You may want to do the formula twice on the calculator, just to make sure you don't have a typo. So that's binary math. Did I tell you it would be easy? I know, you're probably looking at me right now going, I didn't think it was that easy. No, I think you should have. And if you didn't, go back and watch this again. Just like I promised you in the beginning, this is something that you should be able to do without having to have a passion for math like I do, or even being very good at it. Okay, you should be able to do very, very simplistic mathematical functions. And as I showed you just now at the end, if you have to, you can even use the calculator. But it's very important that you do understand the binary math, because a couple of the lessons we're about to get into, you're really going to struggle with if you don't. So that's all I have for you. There's nothing else I can tell you when it comes to binary math. So I will see you in the next lesson.